This lesson is on function combinations, and we're going to look at this algebraically and graphically and using tables. And so you may have only done this algebraically in previous classes. So the first thing we're going to do is we're going to let f of x be 2x plus 1 and g of x be x squared plus 2x minus 1. And we're going to find the following things. The first thing, we're just adding, and so that's really simple. That's f plus g is the same thing as having f of x plus g of x. And again, I want to take this time to mention that this f plus g of x is not multiplication with x. This is function notation written slightly different. So don't get an answer and multiply everything by x. That's not what we mean. Here, we just mean take your f equation and add it to your g equation. It's like this is our set of directions, and this tells us that our variable is x. So I'm going to take my f, which is 2x plus 1. I'm going to add it to my g, which is x squared plus 2x minus 1. And from there, I just have to combine like terms. So I'm going to have x squared plus 4x. And the positive 1 and the negative 1 will go to 0. This will be my final answer. For our second problem, we're doing g minus f, and anytime that you are subtracting, you want to make sure that you put that second function in parentheses so that you get all of the signs right. Otherwise, you'll miss something. So I don't have to worry about the g so much. I'm just going to write it down. So I'm going to do the g and subtract the f. And again, when I subtract the f, I'm going to put the whole thing in parentheses so that I get my signs correct, because I'm subtracting that whole function. So I have x squared plus 2x minus 1. Distribute the negative. I get negative 2x minus 1. And then I can combine like terms. So I have x squared, 2x and negative 2x cancel. Negative 1 and negative 1 is negative 2. So this becomes x squared minus 2. For number 3, we have f times g, and so they don't put a dot between those, they just put them beside each other. They could also write that as f of x, g of x separately, but that still means that we need to multiply. And you want to make sure that you put these in parentheses. So f, I'm going to say I have 2x plus 1. G, I put a big parentheses, and I have x squared plus 2x minus 1. Here you want to be careful. You're having to triple distribute here. So you need to take that 2x, multiply by everything in the second parenthesis, and then take the 1 and multiply it by everything in the second parenthesis. So you should end up with 6 things listed out. So I have 2x times x squared would be 2x cubed. 2x times 2x is 4x squared. And then 2x times negative 1 is negative 2x. So that's the first thing by everything in the second parentheses. I'm going to do the next thing by everything in the second parentheses. So 1. 1 times x squared is x squared. 1 times 2x is 2x. And 1 times negative 1 is negative 1. Then I can combine like terms. So I have 2x cubed. I have 4x squared and 1x squared, so that'll be 5x squareds. Again, I have a negative 2x and a positive 2x, so those cancel each other out, go to 0. But I have that minus 1 on the end. So my answer ends up to be this polynomial here. Okay, with the number 4 example, we have f divided by g, and the nice thing about these is a lot of times when it's the division, there's not a whole lot you can do. I have the f, which is 2x plus 1. I put it on top of the g, which is x squared plus 2x minus 1. Occasionally you can simplify this. The bottom, if it factors to something that will cancel with the top, you can do that, but this one doesn't. So we're done at this point. It's just as easy as writing it down. Now, example 5 has this little O, and that means it's a composition, f of g of x. You may have also seen this written f g x like this in the past, and I actually like this notation better, and I often rewrite it like this. And you want to think of this as substitution. So think substitution. In this case, you're putting the g inside of the f. What I tend to do is I use this notation, and I take the g out and I write whatever its function is in here. Because we've done problems like that where I ask you to plug different things into the f equation. And so what I do then is write my f equation and leave the x out and then fill in what I have here in parentheses. So I plug that in to that hole that I would normally have an x in. And at that point I can simplify. So I would distribute the 2 through, so I get 2x squared plus 4x minus 2, bring down my plus 1, and then combine like terms. So 2x squared plus 4x minus 1. And that is my answer for that one. For example 6, we have g of f of x. So again, I'm going to rewrite it because I like the other notation better. And that reminds me that I am plugging f into g. I'm substituting f into g. And you don't have to do it this way. I like to do it. It makes sense to me. If I take the f out and I plug in its formula, which is 2x plus 1, that tells me what I'm plugging into g. Now my g equation has x's in 2 places. I want to make sure I take both of those out. So my g has x squared plus 2x minus 1. So I want to leave holes for both x's and then fill in that 2x plus 1. Now this one is going to take a little bit more work because of this squared right here with the plus in here. I'm going to have to FOIL. So 2x plus 1 times 2x plus 1 for that piece. So I'm going to do a little bit more work. I can go ahead and distribute this 2 over here in, so I get 4x plus 2 and bring down my minus 1. And then on my next line I can go ahead and FOIL. So 2x times 2x would be 4x squared, then plus 2x plus 2x plus 1. I can bring down that 4x. I'm going to go ahead and say 2 minus 1 is 1. And then I'm going to finally combine like terms again and finish. So I have 2x, 2x, and 4x. So that'll make 8x. And then 1 and 1 will make 2. So I end up here with another polynomial. Okay, and for my last example in this section, I have f minus g of 1. I want you to think of that separately. I want you to think of that as f of 1 minus g of 1. And then I'm going to come over here. F of 1 means I'm just plugging 1 into f. And so that would be 2 times 1 plus 1. So that would be 3. And then I'm going to plug 1 into g. So that would be 1 squared plus 2 times 1 minus 1. So 1 plus 2 is 3, minus 1 is 2. Once I get those two answers, I just look at them, plug them back in over here. I have 3 minus 2, and so my final answer is 1. If you have a combination that has a number like this instead of the x like I did in the first 6, you should get a number answer. You should get a single number answer out. Okay, now we're going to move down to how to do this when you're given a table. And when you're given a table, your questions will all involve numbers just like example 7 did. We just don't have the formulas for them, so they go ahead and give us those outputs. Okay, so we'll start with example 8. I have f plus g of 3, and so I just want you to look at that separately, again, as if it were f of 3 plus g of 3. And we'll look those values up in the table. So f of 3, we're on the f line, and the x value of 3, so we come down and that's this 2. So that it will be 2. And then g of 3, you're on the g line at the x value of 3, and you get a 1. And 2 plus 1 is 3. So that is our answer for number 8. Number 9 is just as simple. We have f times g. So you're doing f of 0 times g of 0. F of 0, I'm going to look up the x value of 0 and the f, and so that'll be a value of 1. I'm going to multiply that with g value at 0, which is 4. And then 1 times 4 is 4. So that was fairly simple. Where it gets a little more complicated is when you do a composition. So I have 10 and 11 as compositions, f of g of x, and again they could use that other notation with that little bitty o. It's the same thing, but I like this one. I just work from the inside out. The first thing I do is work on the inside and just focus on finding g of 2. So g of 2 would be 4, and I'm going to replace that inside here with 4. So I'm going to be looking at f of 4. And then I look up f of 4, and f of 4 is 1. So my overall answer is 1. So I get the answer for g of 2, and then I use that and find f of 4. Okay, so we'll do that again with 11. If you want to try that on your own, pause and try it on your own. If not, you can continue. Okay, so if you paused and tried it on your own, hopefully you did. If you found f of 3, you would get 2, and your problem would become g of 2, and you look that up, you get 4. So 4 is your final answer. Now, the last thing is interesting, and it's inverse, and we're going to do more with inverses in the future. But if you remember from past uses of inverses in other math classes, inverses switch x and y. And so if I say f inverse of 0, I am giving you a y value, just like we talked about on the graphs, just like what we talked about with inverse trig. I'm giving you a y value here. So I'm looking for a y value on f of 0, and that will be right here. And my answer will be the x value, because inverse always switches what we're doing. Okay, so when you get to a graph problem, you're going to actually use the graph very similar to what we just did with the table. When you get a question like 13, f plus g of negative 2, you're going to think of that as f of negative 2 plus g of negative 2. And then you're going to look up those values. So f of negative 2, we're looking at the green graph. Negative 2 is right here on our x-axis, so we look at the y value. And the y value here is 2. So f of negative 2 is 2. And then when we're finding g of negative 2, we have the orange graph, and we're looking at its y value. So on negative 2, it has a y value of 0. And so then I just add those together. 2 plus 0 is 2. And then for 14, g minus f of 1. Again, very similar. Just think of it as g of 1 minus f of 1 and find those y values. So g of 1, I'm looking at the orange graph, at 1, the y value is 1. F of 1, at 1, the y value on the green graph is 0. And 1 minus 0 is 1. So I have an answer of 1 for number 14. Now, our last two problems are going to be graphs with x. Okay, so 15, we're going to graph f plus g of x. And so what I'm going to do is I'm going to look at the points on f and the points on g. So the special points. So if we scroll up, I'm going to label those. On f, we have the point. On f, we have the point negative 2, 2. The point negative 1, 0, the point 0, 1, the point 1, 0, and the point 2, 2. On G, at those same places, I have points of negative 2, 0, negative 1, 1, also 0, 1. Right here I have 1, 1. And then I also have over here 2, 1. So I'm just labeling any points that I can, and I'm going to use those to add to get my graph. When I'm doing question 15 and I'm adding the y values. So at -2, I'm going to add 2 and 0 to get my new y value for my point where they're together. And I'm going to do that for each x value. I'm going to add the y values of the two functions together. So I'm going to scroll back down and start doing that. Okay, so I'm going to create one graph by adding the y values together. So at -2, I have a y value of 0 and a y value of 2. 0 and 2 is 2. So I'm going to plot a point. At -1, I have a y value of 0 and a y value of 1. 0 and 1 is 1. So I'm going to plot a point there. At 0, both of them are at 1, so I add the y values together and I get 2. At 1, 1 is at 0, the one on F is at 0, the one on G is at 1, 0 and 1 is 1. And then at 2, F is at 2, G is at 1, 2 and 1 is 3. And so all you have to do is connect the dots in the order that you found them. And so this is the graph of F plus G. Okay, our last example, we're going to do a composition, and this graph is going to come out really weird, but I'm going to use those same x values, and I'm just going to find each one of these outputs. So I'm going to find g of f of -2, g of f of -1, g of f of 0, g of f of 1, and g of f of 2. And I'm going to get those outputs and plot the points and connect them like we just did. Now I'll go ahead and tell you I've done this one before, and this graph isn't quite as interesting as the addition graph. If I had started with a different f and g, it might have had a little more interest to it. So here, I'm going to do g of f of -2. f of -2 is 2. And then I find g of 2, and g of 2 is 1. So at -2, I'm going to plot a 1. Then I'm going to go to the next one. f of -1. f of -1 is 1. So I'm going to say f of -1 is 0. So g of 0. And then g at 0 is 1. So this point is also going to be at 1. Then to find out where my next point is, g of f of 0, f of 0 is 1. So I'm finding g of 1, and g of 1 yet again is 1. So I'm plotting another 1. Like I said, this isn't that interesting because all these answers are coming out very boring, but sometimes you can get some different things. And then I'm going to do the next one, f of 1. f of 1 is 0. So again, I'm doing g of 0, which is 1. And then the final one, f of 2, is 2. And g of 2 is also 1. So if I connect them, this graph made a straight line, horizontal line. Not that interesting, but it is a graph of this particular composition. And it could get more interesting if we had different g and f graphs to start with. But that's the basic idea of it, and hope you understood algebraically, using tables, and with graphs.